To another section in triangle congruence. This time we are going to actually talk about congruent figures for TC4. So figures are congruent. We've talked about congruent segments, we've talked about congruent angles, and for those we said the figures are congruent when they have the same measures. Now for congruent shapes, like for pentagons and quadrilaterals and triangles, congruent figures are congruent when all of their corresponding parts are congruent. All corresponding parts are congruent. So that would be all the sides are congruent, all the angles are congruent, all the diagonals are congruent, any parts that correspond. Now, what are corresponding parts? Corresponding parts are angles or segments that have the same position. Angles or segments with the same position in their respective figures. Angles or segments with the same position in their respective figures. So we've already talked about corresponding angles on parallel lines, when a transversal intersects parallel lines, but figures will also have corresponding parts. They don't even have to be oriented the same way. As long as they have the same position within their respective figure, they will be considered corresponding. Congruent segments, a congruence statement is one that says that these two figures are congruent. So when we talked about angles being congruent, we had a congruent statement. Angle A is congruent to angle B. A congruent statement for figures with vertices like triangles and quadrilaterals and pentagons. It's a statement that says these two figures are congruent. It would look like an example. So I'll write that first. Statement that two figures or two or more figures are congruent. Let's write that a little bit better. Congruent. Statement that two or more figures are congruent. That's a little bit fuzzy. There, that's a little clearer. So for example, triangle ABC is congruent to triangle DEF. This would mean that not only are these two figures congruent, but all of their corresponding parts in the order that I've written them are congruent. So A is congruent to D, angle B is congruent to angle E, angle C is congruent to angle F. Not only that, but the order that I've written them, side AB, segment AB, would be congruent to segment DE, and segment BC is congruent to segment EF. The position that I've written the letters in tells us which parts are the corresponding parts. They have the same position within their figure. So when two figures are congruent, all corresponding segments are congruent. All corresponding angles are congruent. When two figures are congruent, all corresponding segments are congruent, and all corresponding angles are congruent. So in this first example, this is a congruent statement that this pentagon is congruent to this pentagon. A, B, C, D, E. There's 5 vertices here, 5 vertices here. The order that they're written in tells us what parts correspond. So saying A, B, C, D, E is congruent to F, G, H, I, J is telling us not only are these two figures congruent, but it tells us what parts are. So A is congruent to F, A is congruent to F, B is congruent to G, B is congruent to G, C congruent to H. And notice I'm putting a different number of markings on these, so 3 for 3, 2 for 2, 1 for 1. And it's going in that this one's going clockwise, this one's going counterclockwise, but looking at the parts in the order that they're written here, A, B, C, D, E, D is congruent to I, and E is congruent to J. Okay. Not only that, but AB is congruent to FG. BC is congruent to GH. All the way around. Okay, now, we won't often have pentagons to deal with. That's a lot of things to mark up. But what can we conclude? Well, we could even not only just put the markings on there, but we could say that, well, and I guess I won't need to necessarily write anything since I've labeled it this way. But we could say angle A is congruent to angle F. Angle B is congruent to angle G. Angle C, and you may want to speed this up in the video because this is going to take a sec. C is congruent to angle H. Angle D is congruent to angle I, and angle E is congruent to angle J. So when you're asked in our assignment to write out all the corresponding parts that are congruent, this is what we're talking about. And that AB, the segment AB, is congruent to segment FG. We're just looking at the letters that are in the same position, and we're writing them out here. So BC is congruent to GH. CD is congruent to CD, that's HI. HI. DE congruent to IJ. And then finally, notice A and E are on opposite sides of this statement, but A connects to E in the pentagon. So we can still say AE as one of our segments that we're able to list, and FJ would be the one in the corresponding position on the other figure. Now, in this one, we're given some markings on here, and the question is, I think it got deleted, but the question should be, are the figures congruent? Are they congruent? Write a congruent statement, if so. So let's decide, are these figures congruent? In other words, do they have all their corresponding parts congruent? So I see a 4, I see a 4. On either side of that 4, I see those hundreds. I see 15 and 15, 15 and 15. I see 80s in those other corners. I see a 10 on that last side there. So yes, I think they're all congruent. They have all their angles are congruent, all their sides are congruent. So we're going to say yes. And then when we write our congruent statement, we're going to write this quadrilateral by listing the vertices. So A, B, C, D. And you could go in any order as long as the vertices connect to each other. So I can't call one of these like A, C, D, B because we're jumping across the polygon when we do that. We have to go either clockwise or counterclockwise. And I just said that backwards. Clockwise or counterclockwise when we're naming the vertices. But you can start wherever you like. But then with the second one, we can't start wherever we like. We have to start with the corresponding one. So if I started with A here, I need to start with one that's congruent to A in the second figure. So I could start with E. So A is congruent to E. They're both those 80-degree angles. Then the next side I said AB. That was a 15. So 15, E, F. And then BC. BC goes with FG. And then CD goes with GH. So now I have the corresponding parts in the right order that goes with how they look in the figure. Okay? So our corresponding parts match up, saying these two figures are congruent. Let's see some more examples. explain why the following triangles are congruent. Well, I see 3 sides that are marked as congruent. I see 3 angles that are marked as congruent. So we can say all sides and angles, or that's not quite true, all corresponding sides, because not all the sides are congruent, but all the corresponding sides are congruent. All corresponding sides and angles are congruent. Okay, corresponding parts on congruent figures are congruent. Here we got this one's congruent to that one's congruent to that one. We got all 3 angles are congruent, and they share this side, ln. So if we were to be doing this in a proof, say, we could say that, and actually let's do that. We're going to write these as proofs. Just get in the habit. So, well, no, we'll be formalizing our proofs a little bit more in the next section. But we do want to explain with words why they're congruent. So this one we'll leave it as it was. All corresponding parts are congruent. Corresponding parts are congruent. This one, though, we do have to explain why we know that NL is congruent. NL is congruent to LN, and I switched the order on purpose here because notice N is this marked angle on this triangle, but it's L on the other triangle. N corresponds with L on the other triangle, and L in that triangle corresponds with N in the other one. So NL is congruent to LN. Because they're the same figure. When we say that something's congruent to itself, that is the reflexive property. By a reflexive property. So all corresponding parts are congruent. The other ones are marked that way. So we got to revisit those reflexive and symmetric and transitive properties that we learned back in the Geometry Basics unit. On this one, we have 2 angles marked congruent, 2 angles marked congruent. All the sides are marked as congruent. This third angle is not marked as congruent, but we do know that it is because we have either that they're vertical angles, or, since we know that 2 angles on these triangles are congruent, then the third angles must be congruent by the third angles theorem. So we found that out earlier in this unit. So we could either say that angle DEG is congruent to angle, and we'll make sure to list that angle in the same order. So D corresponds with H, so I'm going to say HEF for the second one, because they are vertical angles. I'll use vertical angles. You could also say third angles. And now we know, so all corresponding parts are congruent. All corresponding parts are congruent. So not only the labeled ones, but the unlabeled ones as well. This one, find the value of x given that these triangles are congruent. So here we know that G is 55, H is 65, and R is this 2x plus 30. Now, looking over here, R corresponds with F. Notice R is the first letter, F is the first letter. So this 2x plus 30 is what this angle is. This is also 2x plus 30. You could also, using these 2 angles, find out what this angle is equal to. That's probably the easier route to go here. 55 plus 65 is 120. And if we take that away from 180, we get 60 degrees. So this angle up here is 60. So we could use that fact and the fact that R corresponds with F to say that 2x plus 30 equals 60. So the other route we could have taken is 2x plus 30 plus 55 plus 65 equals 180. We could add those all up. But because we know those two angles and we can find that third one, this one might be our better option. Then 2x plus 30 equals 60, so 2x equals, we can subtract 30, and then divide by 2 to find x is 15. And that's all we needed to find the value of x. So justifying our reasoning, the 2x plus 30 equals 60, those would be equal because those are corresponding parts. Corresponding parts on congruent figures. And then our last example here, use the congruent statement to find missing variables. So we have these two triangles are congruent. Triangle SMA is congruent to triangle RNE. Justify your reasoning. So we're trying to find x and y. In this case, we know this angle is 112, this angle is 37. Using that, we could see if we know that. See, this is 41, this is 26, this is 23. So the markings are a little bit confusing here because it looks like they're marked as if they're congruent, but since this is 26, this is 23, we know that's not the case. We could subtract from 180 to find out what this third angle is, but I don't think we'll need to do that this time because our goal here is to find the missing variables. So we need to, looking at this 16x, that's angle E, and angle E corresponds with angle A. Angle A we know is 112, so we can just say 16x equals 112 and then divide by 16. Which I think, let's see, 16 into 112, I want to say is, let's see, 16 times 8? No. I think so. Oh no, because 16 times 8 would end in 8. I don't have a calculator on me, so we're going to finish that one. Actually, let's finish this last one in class. We'll do this one in class where I have a calculator handy. My mental math is failing me at the moment. So we'll finish this last one in class. We'll do that together. So I'll talk to you then. Bye for now.